Good day viewers, welcome to another mathematics presentation. So in this presentation I want us to answer this question right here. So the question reads, the diagram below shows the speed time graph of a particle. The particle started off from rest and accelerated uniformly for 10 seconds. It then traveled at a constant speed for 20 seconds and then decelerated to rest. So this is the particle. Okay, this is the diagram showing the speed time graph of a particle. Okay, so this particle started off from rest from here and accelerated uniformly for 10 seconds at the speed of v right here, as you can see. So we have question A, find the speed v the particle reached if its acceleration was 2 meters per second square in the first 10 seconds. So they have given you the speed here. Okay, they have given you the speed which is v right here, and you have been given the acceleration from here to here. So to find this v, you're just going to say acceleration equal to final velocity minus initial velocity over the time taken. Okay, this is the formula that you are going to use. So what you are going to do here is this. When we correct our data right here, so acceleration have been given in the question, which is 2 meters per second square. Then the final velocity. So here is the initial velocity. The final velocity is v. We don't have anything, so just maintain the v. Then the initial velocity is a 0 from here. So supposed to have a 0 here. Okay. Then time. Time they have said in the first 10 seconds right here. So where there is a, we'll put 2. Final velocity we maintain v is what we want. The initial velocity is 0 over the time is 10. So from here, what are we going to do? So from here, we'll say 2 is equal to v minus 0 is still a v over 10. So we divide this by 1, then cross multiply. 1 times v, it's v equal to 2 times 10. We'll get a 20. So v is equal to 20 meters per second. So this is the value of v. So right here, there was a 20 meters per second. We have answered our first question. So let us now move on to question B. So this is our question B right here. Given that the total distance covered was 750 meters. So the total distance for this entire journey was 750 meters. Find the value of t in the diagram. So we need to find the value of this t in this diagram. So how can we find the value of t? So you can see this that we have, it is a trapezium. Okay, it's a trapezium. All right, so this is just written this trapezium right here. This is what we have. Okay, so for distance under this graph, we are considering the area of this trapezium. Okay, so we are going to come up with the formula for finding the area of the trapezium, which we will name as distance is equal to, so it's a plus b in brackets times h over 2. So this is the formula. So a is here, b is from here to here, then the height is from here to here. This is our height. So if you're using this one, a is from here to here, b is from here to here, the height is this one. This is what I've indicated here. So to find this a, you find the difference between this 30 and a 10. So you say 30 minus 10, you get a 20. So meaning that a is equal to 20 here. From here to here, a is equal to 20. Then for b is from here to here. So this will be t minus 0. So t minus 0 will give us a t. So for this b is equal to t. Then the height is from here to here. So what did we say? From here to here, we have a v here. So v, we found that it's a 20. So height is equal to 20. So this is what you are going to substitute here. Then distance, we have been given that is 750. So we are going to write it. Where there is a, we'll put a 20, plus where there is b, we have said b, it's a t, in brackets, height, it's a 20. Okay, over 2 equal to. So where there is distance, we'll put 750. I hope you are following here. So what you are going to do here, 2 here, 1, 2 into 20, it's a 10. So we have 20 plus t, then a 10 here is equal to 750. Okay, this is what you get. This is what you get. So now from here we can say 10 times we can expand 10 times 20. This will give us 200 plus 10t is equal to 750. So from here, what are we going to do? We can let this 200 go to where 750 is. So we remain with 10t is equal to 750 minus 200. So we are going to have 10t is equal to, so 0 minus 0, it's a 0, 5 minus 0, it's a 5, 7 minus 2, this will give us a 5. Okay, so meaning that 750 minus 200 will get 550. So we can divide here by 10, even this side by 10. So what are we going to get? We are going to say t is equal to this and this out, this 0 and this 0 out, 1 into 55, we will get 55 seconds. So the value of t is equal to 55 what? Seconds. I hope this is clear. So meaning that on this diagram here, where there is this t, the time was 55. So here we had the 55 seconds because this is time measured in seconds. So here there was a 55 seconds. So we have answered this question. Okay, so make sure that you can pause the video, you go through the solutions. So let us now find the last question. See, what was the speed at 40 seconds? So what was the speed at 40 seconds? So let's do this. What was the speed at 40 seconds? 2 marks. So they want us to find the speed at 40 seconds. So when you look at this diagram, I've just drawn this one. So let's assume that the 40 seconds is right here. This is where we have the 40 seconds. So I want to find the speed which is at this point. I want to find the speed at this point. So what you are going to do is this. I'll get this part, okay? Then I'll write it like this. So this is where we have a 40, and here we have a 30, here we had a 55. Then here there was a 20 that we found, which is right here. Okay, so I've just gotten this part. We have said the 40 is somewhere here. So I've gotten this part. This is the part that I've written so that we'll be able to find the speed which is right here. So we can find the length from here to here. So to find the length from here to here, we will get 55, take away 30. Okay, here we have 5 minus 3, say 25. So here we are going to have a 25. Then we can also find the distance from here to here. So which is 55, take away 40. So this will be 5 minus 0, it's a 5. Then 5 minus 4, it's a 1. So from here to here, we are going to have a 15. This is the length from here to here. Then this is the length for the bigger length. It's a bigger length. So what you are going to hear is the idea of similarity and congruence. Okay, so we want to find the speed at this point. We can even put that we have a y here. So what you are going to do is we start equating. We get this speed for the, we equate it with the bigger length, which is 25. Then we can get this smaller speed, which is y. We equate it with this smaller length for this from here to here, which is a 15. So we can now find the value of y. Once we find the value of y, it means we have found the speed. So we cross multiply here. We are going to have y times 25 is equal to 20 times 15. So we can divide by 25 here. Even here we divide by 25. So we can say this and this out, y equal to, so from here, let me break this. So I'll say 4 times 5 gives me 20. Again, this one will say 3 times 5 gives us 15. Then this one also break it, 5 times 5 gives us 25. This is paper 1, okay? So you need to know how to manipulate this. Y equal to, so I'll cancel this 5 and this 5, this 5 and this 5. So I'll remain with 4 times 3, which will give me 12 meters per second. So therefore, speed is equal to 12 meters per second. So this was the speed at 40 seconds. Okay, this was the speed at 40 seconds. So we are done answering this entire question. Okay, thank you so much everybody. Please ensure that you go through. This has been your presenter, Mr. Mlenga. Bye bye.